Good afternoon. My name is Joe Dennis. I'm the Vice President and Chief Technical Officer for Surface Tech, and I want to welcome you today to our webinar entitled Planes, Trains, Automobiles, and Boats, Application of Aramid Fiber Reinforced Asphalt Pavement. We will be going ahead and getting started as people get on, and so we have a number of folks attending today. And again, thank you for your time. Thank you for joining us today. And I hope everybody is doing safe. A little bit of housekeeping before we get into the presentation today. If you haven't attended a GoToMeeting or a GoToWebinar meeting in the past, you'll notice your audio is automatically muted. With hundreds of attendees, very difficult for everybody to have an open mic. So in order to ask questions, you'll notice on your control panel a question feature. As moderator, I will be monitoring those questions throughout the presentation and do my best to either answer them in writing back to you and or save some for the end. So please go ahead and send your questions as they come up, and we'll do our best to get to those during or at the end of the presentation. You will be earning one professional development hour that will be sent to you in the follow-up email. And all attendees will also receive a copy of the webinar in a follow-up email. And this webinar will also be uploaded to our YouTube channel for later reference should you want to pass it on to other folks. So with that, let's get started. So as I mentioned, I'm Joe Dennis. I'm the Vice President, Chief Technical Officer here at Surface Tech. I've been around the engineering community and construction products community for well over 30 years now. I've been around the ACE XP polymer fiber products since 2015. And in 2017, I joined Surface Tech directly and have held this title since. So I look forward to being your moderator today, and it's my pleasure to introduce two of our leaders in the Canadian market. Michael Simons is our technical director in Canada. He hails out of the Toronto area, and you can see Mike has got a wealth of experience as well throughout his career, both being engineering related, engineered product related, distributor related, manufacturer related. And as is the case, Mike has been around and promoting and selling this product since 2016. So Mike, welcome today. Our second presenter today is Alex Snell. He's our account manager in more of Western Canada. He hails out of Calgary. And the two of these guys will be sharing some really unique projects later in the presentation today. And Alex will have a big hand in making that happen. We're very pleased to have both of these folks on our team in Canada. And with that, I'm going to go ahead and turn it over to Mike Simons, who will start the presentation.
Thanks, Joe. I hope everyone can hear me all right.
Sound good, Mike. Go ahead.
All right. Can you make sure I have the control, Joe, so I can switch the slides here? All right. Joe, I don't think you've handed over control to me. All right. First technical glitch. We're a few minutes in. Joe? All right. All right. I think we've got it now.
Yeah, you're good.
All right. Thank you. All right. Thanks, Joe. Chances are, if you're on this webinar, then you are familiar with pavement distresses. How you manage these distresses will impact on achieving the full service life of your pavement. Using a technology that can help to mitigate these distresses should be a tool that everyone is aware of and is comfortable using. The purpose of adding fiber reinforcement to a material is to compensate for weaknesses in the main material. An asphalt reinforcement additive should compensate for the brittle, temperature, and load-sensitive nature of unreinforced asphalt mixes. Ideally, it should provide a mechanical connection between the aggregate and the asphalt binder. That's a purely chemical bond, so supplementing it would be very good. A material that has been found to satisfy these requirements is something called Aramid. So before I go any further, I'd just like to find out how everybody is with the state of their current pavement. So Joe, could you roll out the poll?
Yes, let's see here. Let's go ahead and launch the poll question. So I'll go ahead and ask the question. Are you happy with the performance of your current asphalt pavements? If everybody would take a moment, I'll leave the poll open. This is kind of live, and we'll roll up the answers here as they come in. Let's see here. Let's give it a few minutes. We've got %70 of the vote in, 72. Hey, you're doing good. So Mike, well, just on the light side of things, how much snow do you have up there where you're sitting?
I think we're sitting at about 150 millimeters in the Toronto area right now. Some will be a little bit more, some will be a little bit less. Alex, what do you have?
Unmuted.
Here in the mountains, we're actually doing really well. It's no snow, which is surprising for Calgary.
Nice. Joe, how are we doing?
I'm going to go ahead and close this and share the results here. So,
all right.
Can you see those results or not?
I can definitely see them.
Okay, there you go.
Well, looks like most people on the webinar today are interested in looking for ways to improve them, which is good. I think you might be very interested in what we're presenting here. Was expecting a little bit more on the local pushback on contractors, so it's nice to see that that doesn't happen all that much. So let's carry on, Joe.
Yeah, I'm going to go ahead and hide this and go right ahead.
All right. Okay. Got a lag here, Joe. All right. So what is Aramid? Aramid is a synthetic high-performance dry polymer that looks like a fiber. It has 5 times the strength of steel with a very low strain, therefore making Aramid strain compatible within an asphalt mixture. Keep in mind, asphalt's a brittle mixture, so you want something that's going to mobilize its strength without an awful lot of movement. The high temperatures required for asphalt production are well below the melting temperature of Aramid. Unlike cellulose fiber, Aramid does not absorb asphalt cement. Aramid is a non-toxic material that is very lightweight. In some applications, Aramid is used to replace asbestos because of that. In order to prevent the Aramid from floating on air currents and being sucked into a dust collection system, it must be treated with a material that will provide mass to the Aramid, but is also compatible with asphalt cement. So what does Aramid look like and how does it work? If you were to look at an enlarged view of Aramid, you will see that it has a very rough surface texture. This texture allows it to grab onto aggregate surfaces and to root into asphalt binder, creating a flexible mechanical bond and creating a 3-dimensional reinforced composite material when it's mixed with the asphalt. So how do we get these lightweight Aramid fibers into the asphalt? Good question. Aramid needs to be treated in order to get it into the mix with the aggregates. The combination of Aramid polymer and treatment is what we call ACE-XP polymer fiber. ACE-XP polymer fiber is a proven technology that increases the strength, crack resistance, rut resistance, fatigue life, toughness, and service life of any asphalt concrete mixture. Best described as a bundle, each piece of ACE-XP is 38 millimeters long and approximately 2 millimeters in diameter. The bundles can be pulled apart at the ends to reveal the small Aramid fiber, and you can see just how small those really are. ACE-XP is a combination of Aramid, polymer, and sassabit wax. 65 grams of Aramid is combined with 65 grams of sassabit wax, making 130 grams of ACE-XP polymer fiber. We call this a single dose. Several spools of Aramid are pulled together to combine 12,000 individual fibers into each bundle before it is coated with the wax and then cut to a length of 38 millimeters. The wax melts at 77 degrees Celsius, releasing the Aramid fiber almost immediately when mixed in with the heated aggregate and wrap. As the wax melts, over 10 million fibers are released in every ton of asphalt mix produced. Sasabit becomes fully soluble in liquid asphalt binder, and it will not show up in the final mix. The volumetric properties of the original asphalt mix design are not in any way changed with the addition of ACE-XP. Now that we know how each bundle of ACE-XP is made, you are most likely asking yourself, how do you mix it with the asphalt? There are two basic types of asphalt production plants, drum and batch. ACE-XP can be used in either facility. The bundles are added to the plant where you add wrap during the mixing process, so either through the wrap collar on a drum plant or into the way hopper on a pug mill in a batch plant. The key requirement is that we have 25 to 30 seconds of mixing time with the heated aggregate prior to the addition of asphalt cement in order to strip the wax and allow for the interaction of the aramid with the aggregate. Like the aggregate and asphalt binder, ACE-XP needs to be introduced into the asphalt mix in a constant stream-like feed. Depending upon the size of the project, this can be accomplished by using automated or manual dosing systems as shown here. The mass of ACE-XP added over a 60-second interval is dependent upon the production speed of the plant. The goal is to keep the ACE-XP dosage constant, with the variable being the number of tons a minute produced. When added or mixed correctly, the reinforced asphalt mix is easily absorbed at the point of discharge, as can be seen here. Improperly mixed asphalt is easily obtained by the presence of mostly intact bundles, thus requiring an increase in the mixing time or a rethink as to where the bundles are being added into the plant. So what about placing this stuff? Nothing changes in the field when placing aramid fiber reinforced asphalt. If you are familiar with SMA mixes, this is a very noticeable difference. If you look at the asphalt rake or any other tool, fibers can be seen on the edges of tools and equipment. Once placed and compacted, there's no visual difference between reinforced and unreinforced asphalt pavement. So now that we know how to make and place fiber reinforced asphalt, your next question is likely, how does the aramid affect the design of the pavement? As with any engineered product, there's been extensive testing conducted to determine how aramid affects asphalt pavement. Lab and field testing has been carried out across North America and continues to be done to determine how to quantify the benefits of aramid in ACE-XP polymer fiber. All the testing is pointing to this. ACE-XP polymer fiber will add strength to any standard or polymer modified mix design and improve crack and rut control at the same time. As I mentioned, we are constantly involved in research projects to expand our understanding of the mechanisms of aramid fiber reinforced asphalt pavement. We are currently involved in a project at NCAT looking at asphalt additives. The addition of ACE-XP to your asphalt pavement will result in a pavement which is much more resistant to rutting and cracking. It will not stop your pavement from cracking, but it will take longer for the cracking to progress to the point where it would require maintenance. One way to quantify the benefit of adding ACE-XP to your asphalt mix is to look at the performance in terms of a binder modification without actually using a polymer modified binder. ACE-XP will increase the rutting and cracking performance of the mix by 1 grade bump in the high and low temperature grades. So an asphalt mix made using PG 58-28 would be expected to perform like it was a mix made using PG 64-34. Another way to quantify the improved performance is to look at the effect as a design variable. Back calculation from our field testing has shown that the layer coefficient used in an AASHTO 93 design can be increased by between 25 and 30%. If you are currently using a value of 0.42 for your asphalt coefficient, the addition of ACE-XP would allow you to use 0.53 for the design. Engineers love to use design charts. They can be a very useful place to start when you're evaluating your options for asphalt overlays. Given the existing conditions of your pavement and the anticipated traffic loads, it is possible to determine what dosage of aramid fiber reinforcement will be most effective for your project. For overlays on thick asphalt pavements with deep working cracks or overlays on concrete, a single dose of aramid will not be sufficient to solve your cracking problem. In this situation, it will be necessary to call in the ARMI. More on that later. Okay, so much for the technical stuff. Now on to the projects. This is probably what most of you are interested in. I'll now turn this webinar over to my colleague, Alex. Alex spent a good part of this year traveling across parts of Canada to work on some of these projects. Alex?
Thank you, Mike. Welcome, everybody. My name is Alex Snell, and as Mike mentioned, I had the great opportunity to work with many of you this year. And it's a real privilege to give you just a snapshot of some of the exciting projects that have come out of 2020. Just as you'll see in these project profiles, we wanted to showcase work that's being done across Canada with their unique and different applications that were being used. Thus, the title of this presentation being Planes, Trains, Automobiles, and Boats. Now, as we go through, please remember that if you have any questions, feel free to submit them. So without delay, let's start with the planes. Do I have access? Okay, so welcome to northern Manitoba, where the polar bears roam and the northern lights are bright. Churchill is located just on the west shore of the Hudson Bay, and the really only accessible ways of getting this far north is either by train or by plane. Churchill Airport, it may be small, but it is used a lot to transport goods, services, and of course people. It is an incredible asset to have for everyone here. A repair and servicing plan was called upon by the airport and Transport Canada, and with the help of Associated Engineering, Englobe, and our asphalt producer and paver, Nelson River Construction, work started on runway 1533 and taxiway A this last August. As you can see, approximately 7,800 tons of reinforced asphalt was produced at Nelson River's portable plant, which was located right next to the airport. The process was done very simply. With the use of an airline hose inserted at the wrap collar, a steady flow of ACE-XP was injected into the dry mix just prior to the asphalt cement. With a binder of a PG 5240, no wrap was used in this project. It was a fantastic final product thanks to the crew from Nelson River. Nelson River had a lab set up beside the plant and did regular testing for quality control along with regular compaction testing. Some great benefits to this project is the team did not have to make any changes to their plant to facilitate the use of aramid fibers. In fact, no change to the mix design was necessary at all. Some other great benefits that Mike had touched prior was the strengthening and providing a longer lasting life to the affected areas. As you can guess, it would be extremely expensive to have all of this equipment come up to northern Canada. However, if we can help provide even more years before the next repair or activation of a rehabilitation program, it will provide a great overall value to the property. Now, let's take a look at a very busy piece of road in British Columbia. Near Vancouver, the South Fraser Perimeter Road is approximately a 40-kilometer expressway along the south side of the Fraser River. And this 4-lane road was fully open in December of 2013, which allows drivers to travel from Deltaport Way to 176th Street in Surrey, with connections to highways 1, 15, 91, 99, and the Golden Ears Bridge. This busy roadway provides fast and efficient access between the BC interior and the Vancouver Island. So Tetra Tech reached out to Service Tech, informing us that the FTG Fraser Transportation Group and BC Transportation had located various localized repair work and a 1.7 kilometer lane of pavement rehabilitation that was needed on sections of the South Fraser Perimeter Road. This was a fantastic opportunity to introduce reinforced asphalt in these larger strip areas, which had a need for that extra support. In fact, this project presented a unique feature of providing a single dose of ACE-XP as well as a double dose in areas that required the extra strength and support from that heavy traffic. So Lafarge Canada in Langley, BC had previous experience using Aramid fiber in their mix and were quick to respond. And in the August evenings, we were able to produce 1,300 tons of reinforced asphalt using a 19 millimeter class 1 mix design with a PG 6422 and a 0% wrap. This process was also done in the same manner as Churchill, with the use of a line vac unit, pouring a steady stream of ACE-XP in through the wrap color. A fantastic team making the best asphalt for this product. So some of the great benefits to this project are that the team at Lafarge once again did not have to make any changes to their plant or mix design that was needed to facilitate the use of Aramid fibers. Again, with this process of adding fiber that is 5 times the strength of steel, we create a pavement that strengthens and provides a longer lasting life to these heavy traffic areas, while slowing down the development of cracking and mitigating the size of those cracks in this asphalt by adding that mechanical connection between the aggregate and asphalt binder. If we can slow down the activation of a rehabilitation program, that is a win for everyone. Now, I wish to take you to North Vancouver to explain the boat portion of this presentation. So Vancouver, as you may know, is home to many ports. Trade through the Port of Vancouver connects Canadian businesses and consumers with the variety of products that we use every day. Today, I'd just like to quickly showcase the Pembina Pipeline Corporation and their berth dock repair and resurfacing project, along with their unique challenges of having a thin pavement on a moving and shifting dock. So first, I want to thank Kevin Boyer from BA Blacktop for the site pictures and for Xingzhang from Pembina for these early pictures showing the damage. So some of the challenges besides their subbase being a dock is the many heavy traffic loads that were coming and going in the area, creating problems to the pavement, as you can see. One of the bidders proposed of producing reinforced asphalt using Aramid fibers in lieu of using a heavy polymer modified binder. After discussing with the owner, the winning contractor and the owner decided that a polymer binder would be used along with the fibers in order to enhance the overall quality by putting the same thin layer down as if it were a greater thickness of asphalt. This project is scheduled in 2 parts, with the first section done in November of 2020 and the second section being completed for spring of 2021. So BA Blacktop also had previous experience with the use of Aramid fiber and were willing and able to meet the needs of this project. As with the other projects, they used a line vac system to pour ACE-XP into the wrap collar and were able to produce 500 tons of reinforced asphalt along with a PG 7028 and a 0% wrap. Not only were they able to produce the reinforced asphalt, but BA Blacktop were also able to switch back and forth to other business that they had, such as retail work. Again, some of the great benefits to this project is that the team at BA once again did not have to make any permanent changes to their plant or mix design, which allowed them the flexibility to service all of their clients. Adding Aramid fiber increased the overall tensile strength to an already thin pavement, creating that much needed mechanical connection to resist and mitigate cracking due to the thermal, fatigue, and reflecting cracking, giving it the toughness and service life necessary for any port. Finally, I'd like to pass it back to Mike, who's going to go over one more project involving trains. Thank you, everyone. Take it away, Mike.
Thanks, Alex. For our final project, we're heading to Toronto. See if I we did the control here correctly. Our final project will cover off the trains portion, as Alex mentioned. This project is at the CN Brampton Intermodal Terminal, which is located in Brampton, Ontario, just north of Toronto Pearson Airport. CN is engaged in a multi-year upgrade of this facility. 2020 was the second year that CN has used fiber reinforced asphalt pavement at this facility. The 2020 works were designed by Hatch, with Thurber Engineering providing pavement engineering support. Coco Paving was awarded the contract to construct the Pad 8 rehabilitation project. In order to handle the heavy loading due to heavy lift forklifts and loaded shipping containers, a very thick asphalt pavement was required. At 400 millimeter in total thickness, Thurber used fiber reinforcement to optimize the thickness of the bottom lift and to enhance the performance of the surface lift. Approximately 7,000 tons of fiber reinforced asphalt were used on this composite pavement. So you note that they've only used reinforcement in some of these layers, not all of them. The paving operations were done at the end of September 2020 over a 1-week period. Asphalt was produced from 2 of Coco's plants, one in Wolfdale Road in Mississauga and the other at the Coco Maple plant located in Vaughan. Both plants were drum mix. Given the size of the project, an automated MD3 automated dosing machine was used to dose the ACE-XP fiber. The image at the top left shows the hose discharging the ACE-XP bundles into the wrap collar at the plant. A sample of the SP25 mix reinforced, so this is immediately at the discharge, is shown here. In order to complete the paving operations, the paving was done in echelon with multiple crews and multiple material transfer vehicles. And I'd just like to thank Coco Paving for those pictures. So we've spoken about the projects and technical benefits of ACE-XP polymer fiber. I mentioned earlier that sometimes a single dose of Aramid is not going to help. Sometimes not even a double dose would be enough. One of the results of ongoing research is the development of new technologies to address these situations. So let's talk about what's new. There are a lot of discussions occurring across Canada regarding the use of balanced mix design. One of the goals of balanced mix design is to balance the rutting and cracking performance of the mix. The use of ACE-XP can help a contractor achieve a balanced mix using Hamburg Wheel Tracker and Ideal CT performance tests to optimize the mix. We call it our good, better, best, and test program. When you're looking at an overlay on a concrete or a thick asphalt pavement, one of the biggest concerns is the continual movement of the joints or deep cracks. Simply paving over the joints or cracks without accounting for this movement will result in an overlay that will crack within a very short period of time, sometimes within months. ARMI, Aramid Reinforced Mix Interlayer, is a thin paver-laid fine aggregate asphalt mix that produces a very crack-resistant interlayer that is used to construct asphalt overlays on concrete pavements and deep asphalt pavements. ARMI is not a product. It is a mix design created using locally sourced fine aggregates and asphalt binder. Typically, it has a high AC content, typically 8%. ARMI is designed to be a very flexible pavement, as you can see here from this image. This is the material, this is the layer that's going to absorb the movement. The goal of the ARMI mix design is to achieve specific performance targets for rutting and cracking resistance as shown here. Surface Tech will prepare the mix design at a lab in Kentucky using materials provided by the local contractor. The overlay placed above the interlayer is a function of the traffic load. ARMI may be a solution to some of your most distressed pavements. When things are bad, you call in the ARMI. We've got a video outlining ARMI as well. Joe, could you please start the video? Just a warning to everyone, you may want to adjust your volume. It gets a little loud to start off.
Okay, Mike, video, you're back on.
All right, thanks, Joe. Now for our second poll question.
There we go. Let's launch that. So I'll go ahead and ask it, and that is to all on the call here. Would you like to see more recycled asphalt pavement or RAP used if some of the following below are met? So improve crack resistance and lower cost. If you could improve crack resistance at the same cost, if you could the same crack resistance at lower cost, same crack resistance and same cost, or never. And as we talk about this, and we've launched the poll here, recycled asphalt pavement, especially in Canada, has been not always used, and in some cases still not used today, mostly because of the cracking issues that tend to go along with higher RAP mixes. And the reason for that is as we increase RAP, what are we doing? We're decreasing the use of binder content. And that binder is, the lower the binder content you have, the more dry the mix becomes. Gets back to that slide that Mike showed on balanced mix design. And so, the less binder, and of course the binder that's coming off the RAP is not at the same PG grade of the virgin binder going in, again, becoming more of a stiff mix. And today, with all the tools we have and what Mike's going to show here coming up, we have ways to make this all happen today with plant additives that truly can drive the use of RAP beyond where it's been while providing incredible performance. So stay tuned to that. Let's see here, Mike. We've got most of them in. Let's see how these came out.
Thanks, Joe.
Mm-hmm.
All right.
So
Everybody wants a better quality mix at lower cost.
it's a beautiful thing. And hey, one of the components of using more RAP has the likelihood of getting there, as we know. So take it away, Mike. I'll hide this and get back into the presentation.
Thanks. Another new solution from Surface Tech is REARM HR. In order to maximize the amount of RAP that can be used in an asphalt mix, REARM HR has been developed to use a combination of aramid fiber and bio oil to create a mix design that achieves specific performance targets. Using a balanced mix design approach, local aggregates and binder, including the RAP, are used to create an asphalt mix design that matches or exceeds the performance of a traditional low RAP mix while using a much higher RAP content. So Joe, could you start the video?
I certainly will. Okay, Mike, back to
We're
you.
back on. Awesome. Now for a final poll question. You spent the last few minutes looking at how Aramid fiber can benefit pavements. So I'd like to ask everybody participating in this webinar here, do you foresee any potential applications of this technology in the projects you're working on for 2021?
So the poll's open there, Mike.
Yep.
We do have some questions here. Let's
It's awesome.
let me pull these out. Okay. There was here's a question from Jordan, and I'll let you answer this, Mike, as you speak Canadian better than I do, and that is, what's the cost of adding ACE XP in a single dose to a 50 millimeter thick, say 1 kilometer long, 7-meter wide roadway? And it might be easier to give it on a metric ton basis, but
no,
so
that's a great question, Jordan. Thank you for that. For a 50 millimeter lift, we tell owners to budget $15 a ton for the premium for the addition of the Aramid fiber. So to work it back to your 7-meter wide, 50 millimeter thick overlay, it is, okay, I've got the number memorized for a 3.75, so that'd be a little bit more than the 7-meter wide. Essentially, it's just under $2 a square meter for that 50 millimeter overlay, based on $15 a ton.
yeah, $15. Yeah, for plant mix. Right. Okay. All right. Let's see how that poll's going. Well, we still got votes coming in. Let's take another question here. Mike, I don't know if you see that question there, but which asphalt plants, and I'm going to destroy this name, I'm sure. Moncton, ND region? Moncton, thank you. Just like it sounds. ND region are using this system. That was submitted by Tim. Thanks for the question.
Yeah. Thanks, Tim. The fibers have been used from BC across to Quebec and up into the Northwest Territories. Unfortunately, they have not been used yet in the Atlantic provinces. So there are no plants in Moncton that have used the material, but your question, you can basically ask that to any region within Canada, because it's the first question that a contractor is going to ask us is, what is this going to do to my plant? And I can tell you from experience, this is not going to do anything to the contractor's plant. So while no contractors have worked with it, the contractors will not have any issue working with it. Depending on the ownership of your local contractors, we have done work with a lot of companies that are associated with Colos, so anything from the Miller Group out in Atlantic Canada or Ontario. We've done a lot of work with their facilities, Coco Paving, Lafarge facilities, Eurovia plants. These are all companies that have worked with our materials, multiple plants, and we don't have any issues. Alex has only ever really run into an issue with 2 plants out in Western Canada where they couldn't actually use the fibers because the plants were so old they did not even have wrap collars on them. So we wouldn't anticipate any issues with the contractors, but it is a discussion we've had with every plant manager who we worked with, and everyone is satisfied at the end of it that this is not going to modify their plant. So hopefully that answers your question.
Yeah, let me go ahead and close this poll and put this up, and we'll answer some more questions as we kind of get out of our presentation here and into the question and answer section. How did that come out, Mike?
Well,
pretty good.
So So if you would like to share information with your clients, if there's any way that Alex or I can help you with that conversation, we would be happy to work with you. Simple questions right through to design assistance. We're here to support you in the use of this tool.
So there's a couple more questions that have come in. Tony
Perfect.
has submitted a question, and Tony, thanks for this. And this is a great question. And would the fiber be best suited for the addition to the base course or binder course rather than the top course asphalt? It's a great question. And let's see how Mike answers, and I might have another answer. So, but go ahead, Mike. Take a swing.
Yeah, it is a good question, Tony. It has been used in a lot of applications in the base course, and depending on the structure that you're trying to build. If it's a staged pavement, so say you're doing a development project, industrial park, putting the fiber in the binder course, especially if you're running heavy traffic over that pavement before you put a surface course on, that's a great application for it. If your pavement structure is strong enough with the surface course on to carry the design loads, you have the option to reinforce that surface or not. Some owners have reinforced it to get service life out of that. Others have just left it unreinforced. On that, if you're putting it over a severely cracked pavement, which some people have done, the idea a number of years ago would have been just to reinforce that base layer to act as an interlayer. We know that that has not worked, but that's where ARMI has been developed for that. If you're building a new construction, totally new pavement, and you're satisfied with your granular thickness and you're satisfied with your base thickness, some owners are putting it in the top course just to take care of top-down distresses, because that's how they're viewing, or how they've designed the pavement to basically fail, is through top-down only. So it can be used in all layers. The base is a really good place to put it in, but it does really come down to, at the end of the day, what is your anticipated failure mechanism from the pavement you're looking at, and how can we help avoid that problem? Hopefully I passed the test, Joe.
Yeah, no, that was good. And I guess I would make it a little bit more simple. And that is, I think everybody on the call probably recognizes that cracking both happens from the bottom up and the top down. And so my first answer is always going to be to reinforce it all. And because the mechanism of bottom up cracking is different than the mechanism than top down. And certainly from a rutting perspective as well. But as the pavement ages, it's going to dry out. It's going to crack. And so if you've got your reinforcement in the base layer, you're probably not improving the life, if you will, terribly, of that whole aging and drying out. So you're not slowing down that process of the surface if you don't put it there. So it is an interesting discussion, but I think it's one that can be answered that way, and that is, where in your given project, where are the cracking distresses primarily coming? Bottom up or top down? Okay. With that, we've got the questions just keep coming, Mike. So here's a great question from Luke. What effect, if any, does this have on mix if used in RAP? So recycled asphalt pavement. And I believe what he's asking there, Mike, is, can we use ACE, with recycled asphalt pavement? And, much like, I'm sure he's thinking about, some restrictions with regards to polymer modification with RAP, as that tends to make mixes really stiff. As we know, the use of ACE XP actually offsets some of the negative effects of RAP by itself. And so I guess I've answered that question. myself. I apologize for that, Mike. You got anything to offer there?
Yeah. So Luke, I guess to answer your question, yes, we can use the fiber with wrap mixes.
Yes. Jeez. We're going to have to start our own radio show here, Mike. But anyway, the Mike and Joe show. All right, got another question here from, is that Laurent? Did I say that right, Mike? Let's see. Have you ever done projects involving both ACE-XP and fiberglass reinforcement? Any comments? No. How ironic is that? You've done something similar to that.
All right. So I'm assuming that the fiberglass, is it a paving grid, like glass grid, or is it using something like the SAMI? Because the fiberglass has been used in two different applications. If you're looking at using it in conjunction with a glass grid product or any other sort of paving grid, we have done projects in combination with it. Why you want to use the two materials in combination, that would be something that I would like to consider or know about, because in some ways the fiber can replace the grid entirely on that, so it's overkill. It's something that ARMI may replace the fiberglass grid in certain circumstances. ARMI will be more cost effective and easier to install than a paving grid or a paving fabric will be. So we have used them in combination. It's very infrequent. I'm only aware of it in two applications in Canada.
But that kind of speaks to what we just talked about, right? And you got bottom up cracking with the triangle, right? Reflective cracking up back through your overlay. But if you put ACE in the overlay section, now you're helping to prevent top down. So that's if everybody recalls the video we just watched. You know, the best crack mitigation system on the market right now is using ARMI, that 1 inch interlayer. Forgive me for using inches, with inch and a half to 2 inch overlay over the top, all using Aramid Reinforced. And so that mitigates both the bottom up and the top down. Go ahead.
The one project we did was actually using the fiberglass grid on the top of a concrete pavement prior to the application of the reinforced asphalt overlay. But at the time, ARMI was not, basically ARMI was under development. It was not a commercially viable solution at that point.
Yes, and so that speaking of which, that would be one of those applications that we would say would be perfect for the use of both ARMI as the interlayer and ACE-XP and the surface. So anyway, let's see here. So Kamal made a statement, and I thank you for reinforcing what we were saying, Kamal. And it says that the reinforcement placement should be chosen depending on the type of cracking and letting expected or occurred. And so thank you for agreeing with our assessment. Matthew would like you to restate the cost, if you would, of ACE-XP in a single dose. And actually, the double dose gets a little bit less expensive on a ton basis because you're already there doing the mixing. So why don't you throw both of those out there, Mike, for everybody to write back.
So Matthew, when I'm in discussion with owners, I suggest that they look at a budget number of $15 a ton for the supply and dosing of the fiber. Depending upon the size of the project, there's the component which is the supply of the fiber, but then there's also the dosing services. If you're looking at a small project, the dosing may be a larger component than if you're looking at a very large project where we're using the automated machine versus the manual system. The dosing cost can drop quite significantly, and there's a lot of projects that have been well under that $15 a ton. But we tell owners, if you budget $15 a ton, rarely, if ever, has anybody come back and said that that was wildly unrealistic on that. So we find that that's a good number for owners to look at the budget on, and that going back to that previous question about the 50 millimeter overlay, it's $1.82 a square meter, is exactly what $15 works out to on a 50 millimeter overlay. And if you, the question about the grids, I can tell you fiberglass grids are going to cost you an awful lot more than $1.82 just to purchase, let alone the installation of it. And you mitigate any installation risk because you're doing nothing but paving as opposed to having install that reinforcing layer and worrying if your tack coat's been installed correctly. All sorts of risk associated with the installation of a paving fabric or a grid. The use of the fibers mitigates that entirely.
Right, right. Hey, we got some more questions rolling in. Keep them coming, guys. We're here as long as you're asking questions. And you know, for those that need to go ahead and get off, we appreciate your time today. But we're going to keep answering these questions as they keep rolling in. So, Jordan asked another question, and we get this a lot, Mike, and that is, you know, can ACE be used in concrete as well? And as we know, you know, fiber reinforcement has been used in concrete for more than 20 years. So why don't you take a swing at that?
Theoretically, you could use the Aramid fiber. You could use, you couldn't use ACE because there's no way that you would be able to remove the sasabit wax off of the fiber. So if we just look at using Aramid reinforcement, yes, you could use it. There has been research done on it, but it's not a very cost-effective solution in a concrete application because of the amount that you required. We are putting in grams. We're putting in 65 grams in a ton of asphalt. In concrete, when you're using traditional materials, plastic fibers or the steel, you're putting in kilograms of the fiber, and the cost compared to a pure polypropylene fiber, the Aramid is not cost effective in that sort of environment. So you might be able to do it in a lab, but commercially, it's not going to be economically viable, really.
Yeah, and you bring up a great point. You know, polyolefin, polypropylene, you know, has been used in asphalt as well, and at a lower melting temperature, you know, they're not very effective in reinforcing the asphalt. In fact, they tend to melt or become very soft, and what ends up happening is you change those mechanical properties to the point that you don't get a lot of benefit. Okay, so however, that same thing does not happen in concrete because you're mixing it, you know, for all intents and purposes in the coal. And there's a huge cost differential, you know, between an Aramid engineered fiber and, you know, the more readily available polyethylene or polypropylene. So
the reinforcing concrete with fibers is about a 50-year-old technology. And when people realized that they could do that, the next thought was essentially, how can we do this with asphalt? Because asphalt pavement, asphalt concrete, similar idea, but as they say, the devil's in the details. Asphalt's a much hotter material. It's manufactured at much higher temperatures. Concrete, you're looking at maybe 50, 60 degrees Celsius as being the upper end of the temperature, whereas asphalt's produced at 150 plus Celsius. So the original research, there's been about 40 to 50 years research on the use of fibers in asphalt, and a lot of it was around the materials that are being used for concrete, but a lot of them don't survive all that well in the heated environment. One that worked out really quite well was asbestos, but we know that there are some slight environmental issues working with asbestos fibers. So there's been about a...
Oh, go ahead, Mike. I'm sorry.
Yeah, there's been about a 40 to 50 year history of trying to use fiber reinforcement in asphalt, but it's just getting that right material where that's appropriate for the environment, and that's where the Aramid has started to shine through.
Yes, yes. So another great question here from, and forgive me if I say this wrong, but Chaminda, and that is, will using this product affect compaction temperature window? You know, for example, will this help extend paving season? Great question, especially as it relates to polymer modification. Go ahead.
Really good question. So will it affect compaction? Some contractors have found that This can be used as a compaction aid. Will it extend out the paving season? The fibers themselves won't. Use of a warm mix additive, warm mix asphalt, will help with that, which leads to the question, can we use the fibers with warm mix technologies? Yes. The concern about late season paving or extended paving season, because the fibers, when they're in the mix, if the mix is kept above the working temperature for whatever your mix is, and that should be a given for anything, the fibers really don't impede the placement of the asphalt. When the mix cools below that working temperature, though, the presence of the fibers does become very, very evident, and it becomes a little bit harder to actually do hand work when the mix is below the working temperature, and that is an issue when you're dealing with late season paving on that. So it's not going to extend it out. It can be used with warm mix asphalt to extend that out, but when the mix starts to cool down, the fibers are going to be a bit of an issue, but then again, so is your compaction on that.
Yeah,
So
so
hopefully
let's
that answers your
put
question.
let's put another spin on that. Let's just say, and I think we had this happen recently, Mike, and that was I was kind of getting late in the season, and a polymer modified binder was swapped out to a standard binder and added ARMI to it, so they didn't have that late season cooling off. You know, obviously that the polymer modification has to be that asphalt has to be kept at a higher temperature in order to get the compaction. And so, from that standpoint, if you're used to using polymer modification, we can extend the season with a swap out. And I think you had an example of that here recently.
But we have had a couple of inquiries about owners and contractors switching out the binder, the polymer modified binder, and using a non-modified binder with the fibers. And yes, that can be done, be it early season or late season paving.
Right. So kind of on that note, Dan sent on a question here. Is the product easy to work with? And he may have not picked up, but he said the higher AC content makes the hand work harder, and does this product act the same? Will hand work be noticeable? So first of all, you don't need to add AC content to use AC. So let's take that out now. However, on the ARMI product, higher AC content for that interlayer is intrinsic to the design of that interlayer to get such a flexible, pliable asphalt product. So, so let's make that clear. So go ahead and answer the rest of that question.
Well, as you just said, mentioning ARMI is a paper-laid material, so there shouldn't be a lot of hand work when you're dealing with ARMI on that. But in general, adding the fibers, it does not make the mix any harder to work with the exception if the temperatures have cooled down to that point, which is going to be an issue regardless of whether it's reinforced or not. So typically we're not modifying that AC content with the fibers.
Right. And probably the easiest answer, Dan, is whatever the PG grade that's selected, as long as you're in the workable temperature range of that PG grade, you will not notice a difference with workability once ACE is added. Meaning we're not going to make a 5828 any worse or harder to go down, or make a, and you guys don't probably use it up there, but a 7622 any easier to go down. So it'll take the appearance of the binder that's selected, and that's how it'll feel to you as it's going down in normal temperature ranges for that binder selection.
Joe, I don't know if anybody's asked the question, but it's kind of related to this, so I'll ask it and answer it. On occasion, we will get contractors that talk about pickup on the roller when using this material, and the fibers do not cause pickup, but if you're not using release agent in the drum of your roller, well, that tends to be a bigger issue. And usually when I point that on a job site, the question very quickly resolves itself. So using proper techniques, using proper technology, proper release agents, basically doing the job normally, as you should, this is not going to impact on the placement at all. And in fact, some contractors find that perhaps they may get compaction a little bit earlier, a pass quicker, or if they maintain their same number of passes, they may get a little bit higher compaction.
Which makes sense because all of those high tensile fibers are creating a three-dimensional mesh, if you will. So the loose asphalt isn't as loose as it once was. So it's actually going down in a stiffer mat in a loose form than it would be if the fibers weren't there. So achieving that, yeah, go ahead. It's interesting if you've never seen it, but that cold edge, right, Mike? I mean, it virtually stands vertical. So.
Some roller operators have told me that they do feel that the mix is a little bit stiffer, and they do notice that it's a little bit, it stands up better along those along the joints. So they're happy with the way it goes down. It's not making their lives any harder to work with.
Yeah. Hey, Frank Quinn has sent in a note here saying, Mike, that they used it in WMA and it was fine.
Yeah.
So thanks, Frank. We appreciate that.
Thanks, Frank.
Yeah.
It has been used a fair amount using the Evotherm warm mix technology. It's not really commonly used in Canada, but Sasabit in much higher doses than what we're using is used as a warm mix additive in other parts of the world, but it's really not used in Canada. But we wouldn't have any issue because we're already using Sasabit as part of the material. So this is, the warm mix is not an issue.
Yeah. So a couple more here, and it looks like we're going to be winding up. But Nicholas sent in a question, and so his question's interesting, and that is ACE-XP a better application to look into than SuperPave? Would it be beneficial to surface treat ACE-XP asphalt with, and I'm not sure what EN-ONE is, N1 question. So let's handle the SuperPave issue first. To me, SuperPave is an asphalt mix process, not necessarily a product. However, what came out of the SuperPave, let's say 20 years ago, that mix process was the PG binders and polymer modification. So if the question is kind of, is it better than polymer modification? Keep this in mind, and that is when you add ACE, you're going to get improvement in both cracking and running at the same time. Okay. Typically, when you polymer modify, you're going to modify in only one direction, meaning you're going to increase the top grade or the bottom grade of that PG grade to improve rutting or cracking. And up there, I would say in most cases, you're not really doing a lot on the top. It's more about cracking. Well, as you make that grade softer, you always run the risk of going over that line of balanced mix design. And so as you make it softer, as you go to a 5828 or 5864 or whatever you may be doing, or you're making it so soft that you're having a rutting issue. In that case, obviously, we look at ACE-XP as a great balanced mix design tool because as you're making it more crack resistant, you're also not going to give up on the rutting side. And that's also why it works so well in REARM, because that bio oil is doing exactly that. It is softening that oil to compensate for the high wrap quantities that go in that tend to make that mix stiff. And so then the ACE is making sure you're not giving up your rutting performance as compared to normal mix design. And so from that standpoint, we would definitely say it's a great tool to look at to ensure that you're balancing the way you're approaching your mix design, both for the rutting and crack. Did I miss anything there, Mike?
No, you didn't, Joe. Great answer. The fibers have been used with Marshall mix design methods, super pave, FAA mixes. So the mix design method, the use of the fiber is compatible with any of that.
Exactly. So yes, let's see. I think we have in Shamenda, thank you for this. We always get this question and didn't think we were going to get it today, but here it is, Mike. How about recycling this pavement with fiber in the future? Does this stuff affect it negatively? No, it does not, but go ahead.
Yeah, no, it does not negatively affect the pavement. The reinforced pavement can be milled. It has been done in the past, so we know that as the material doesn't change the placement operations, it also doesn't negatively impact on the milling operations when you get to the end of life of a reinforced pavement. The effective cumulative, as you've probably gathered because we've spoken about single dose and double dose, the more aramid you add to the mix, the better it is. So using recycled wrap that is actually made with the aramid fiber just increases the quantity of wrap if you're going to be using in the future fiber reinforced mixes using fiber reinforced wrap. The effect of that is cumulative.
Yes, very good answer, Mike. Hey, I think that pretty well wraps up the questions today. Let me ask you one final wrap-up question, and maybe this will help everybody on the call realize just how much of this is going down in Canada. So you've been involved in the product since 2016, and I hope I'm not throwing you a curveball, but knowing you've got this right on top of your head. How many metric tons have been produced with ACE XP polymer fiber across Canada since 2016?
Probably about 400,000 tons across Canada.
Okay.
Since 2016. The United States is more advanced with the use. This is a technology that started off in the US. So in the US, they're doing millions of tons a year of this material. In Canada, we're doing hundreds of thousands of tons a year of this across the country. Some provinces are not much more advanced, but some provinces are using more of it than others, and sometimes that's a function of the owner who's using it. Sometimes it may be a larger number of smaller owners using it for small projects, but it has been used, as I mentioned earlier, literally from coast to coast across the country.
Very good. Mike, I'll let you say kudos to everybody, and from me as the moderator, thanks for having me today, and I'll talk to you soon.
Yeah. Thank you very much, everybody, and hope that you did enjoy the webinar here today. Thank you very much for your participation. And on behalf of Joe, Alex, and myself, I would like to thank everybody. This webinar has been recorded, and we will be sharing a link with you shortly. So thank you very much, everybody.